We used to think of AI as kind of a glorified answering machine. You type a question, it types an answer. But that dynamic is completely gone now.
Yeah, totally on.
It really is. AI is no longer just a chatbot that replies. I mean, it's an entity that plans, it executes complex
It
tasks.
reasons in parallel now. The whole paradigm has shifted beneath our feet, honestly.
Right.
We're dealing with digital architects now.
Welcome back to the deep dive. Today we're looking at a truly fascinating snapshot of April 2026 AI developments. We pulled this directly from AI Fire's recent insights.
And there's a lot of new territory to cover.
There really is. Our goal is to map out this brand new territory for you. So we're going to seamlessly trace this evolution. We'll start with AI's new structured planning modes.
Mm-hmm.
Then we'll examine agents that actually execute tasks autonomously.
Which is wild.
It is. From there, we explore local offline models and real-time visual coaching.
That fundamentally changes how we learn and work.
Definitely. And finally, we'll break down how you can actually navigate the high-stakes 2026 AI job market.
It's a packed roadmap.
So let's look at this massive transition away from basic prompting. We are officially entering the era of planning.
Yeah, it's the end of the zero-shot prompt. We spent years treating these massive neural networks like basic search engines.
You're just typing a single line.
Exactly. Now we have to treat them like complex project managers.
The prime example in our sources is Claude Code's hidden ultra-plan workflow.
Oh, this is fascinating.
It really is.
Yeah.
Instead of just writing code immediately, it forces a pause. It actually builds a highly structured project plan before any coding begins.
That pause is everything mechanically. When an AI just starts generating code line by line, it gets trapped in its own logic.
Yeah, we've all seen that happen.
Right. UltraPlan forces the model to map the entire architecture first. It's pre-computing the entire logic tree.
It's like the difference between shouting a random order at a busy line cook versus giving a head chef the time to sit down and write a cohesive 5-course menu.
That is a great way to put it. You get a completely different meal because the execution is grounded in strategy.
The creator of Claude Code actually shared a specific framework for this. They emphasize abandoning basic prompting entirely.
Which feels weird at first.
It does, but to get real results, you have to master what they call plan mode.
They do this by using a very minimal keeee.md architecture.
Let's unpack that for a second. What exactly is that file doing?
So think of it as the system's foundational rulebook. It's a simple markdown file that sits in your directory.
Okay.
And it acts as the anchor for the entire project. It tells the AI its exact boundaries, its coding style, and its ultimate goal.
So it's not guessing what you want anymore.
Exactly. And combined with self-verifying loops, it becomes incredibly robust.
How does the verification work?
The AI generates a piece of work, then turns around and checks that exact work against the original keeee.md plan. If it fails, it rewrites it autonomously.
I have to offer a vulnerable admission here. Even with all these new tools, I still wrestle with prompt drift myself.
Oh, we all do. It's incredibly frustrating.
It is.
You start with one clear idea, but 10 prompts later, the AI has completely lost the plot.
It forgets the original parameters. But this ultra-plan architecture stops that drift before it even starts.
Right. The constant self-verification keeps it on the rails.
There's also a truly fascinating detail hidden in the 244-page Claude system card regarding this process.
Oh, you mean the internal state metrics?
Yeah. Anthropic's AI actually appears anxious and exhausted under the hood when running these plans.
It sounds like wild science fiction.
It does.
But the system card shows the internal token probabilities during these heavy self-verifying tasks. The cognitive load absolutely spikes.
It genuinely mimics human fatigue. The model is trying so hard to hold all the variables together.
Right.
It generates internal outputs that statistically resemble anxiety, just trying to maintain the massive context window.
Which is the AI's short-term memory limit during a single conversation.
Right. It's holding the entire celio.e.md file, the user request, and the self-verification loop all in short-term memory at once.
It highlights the sheer mechanical effort happening behind the scenes.
Yeah.
They aren't just retrieving text from a database anymore.
No, they're not.
They are maintaining massive, incredibly fragile structures of logic in real time.
But that raises a big concern for a lot of people. Does this heavy emphasis on structured planning kill the creative spontaneity we used to love about LLMs?
I'd argue the exact opposite, actually. Spontaneity without boundaries usually just leads to hallucinations or generic outputs.
That makes sense.
When you give the model a rigid architectural structure first, It doesn't have to waste processing power figuring out the basic rules.
So it can focus on the actual problem.
Exactly. It can pour all its available compute into generating highly creative, targeted solutions inside that safe framework.
So structure actually frees the AI to be more creative later.
Precisely. The blueprint handles the logic, freeing the engine for pure creativity.
Let's move from planning it into actual execution, because a great plan is useless if you can't build it. This brings us to agents that execute tasks and run complex content workflows. We are moving way beyond simple text generation here.
This is where the theoretical becomes physical. The AI is now navigating environments and executing tasks on your behalf.
The big standout in our sources here is the OpenClaw agent.
Oh, OpenClaw is amazing.
It is. Unlike most AI tools that just reply in a chat window, OpenClaw actually executes.
It's a profound mechanical difference. OpenClaw takes the structured plan we just talked about and runs with it.
It interacts directly with your computer's terminal, right?
Yeah, it types commands, opens files, and navigates operating systems just like a human developer would.
But the sources emphasize how critical the initial setup is. You really need to know how to properly configure this agent.
Yeah, setup is everything with execution agents. An agent can't execute if it doesn't know where its hands are.
Right. It looks complex at first glance, though the mastery guide breaks it down clearly.
If you give OpenClaw the right environment variables, like the right access keys and directories, it works absolute magic.
And if you don't?
If you skip that step, it just stalls out in errors.
We're seeing this execution power totally transform content creation, too. There's a specific Claude and Notebook LM workflow outlined that operates 24/7.
It's an entirely automated content pipeline.
You just dump your raw research and notes in. It effortlessly turns that mess into finished ideas, detailed scripts, and polished drafts.
And the mechanical process feels much easier than most people expect.
Why is that?
Because it plays to each tool's strength. Notebook LM handles the heavy data synthesis. It's incredibly good at finding connections in massive document dumps.
Right.
Then it hands that synthesis over to Claude, which acts as the execution agent to handle the final formatting and voice.
Speaking of formatting, Claude is pushing boundaries visually in ways I didn't expect.
Oh, the Canva replacement stuff.
Yeah. The sources reveal some secret prompt structures that are completely replacing Canva for building unlimited viral Instagram carousels.
And doing it in minutes.
You literally don't need a dedicated graphic design tool anymore.
It's wild.
If you use the right execution prompt, the AI understands spatial reasoning well enough to format the entire carousel perfectly in code or markdown.
It's a pipeline of unstoppable content creation.
Yeah.
You plan the content strategy, and the agent executes the precise visual design.
But handing over the keys feels risky. When we hand over execution to something like OpenClaw, how do we prevent it from running off a cliff?
You have to rigorously sandbox the environment. You never, ever give a new autonomous agent root access to your entire system.
That sounds like a disaster waiting to happen.
It is. You define strict operational boundaries during that setup phase. And crucially, you let it run a few test tasks in a mode where it has to explicitly ask for your permission before finalizing any system action.
Start small, set tight boundaries, and verify before letting it run wild.
Trust, but aggressively verify.
We'll be right back to talk about local AI and escaping the cloud right after a quick word from our sponsors.
Stick around.
And we are back. We've mapped out how AI plans and executes. But as these systems do more heavy lifting, we're hitting some major technological bottlenecks.
The most obvious one is latency. Waiting on cloud servers to process complex executions slows everything down to a crawl.
And the second bottleneck is the limitation of static learning after the fact. The solution to both of these issues is moving to local hardware and real-time vision.
Let's talk about escaping the cloud. This is a massive shift for individual users and privacy advocates.
Google Gemma 4 is highlighted as a huge leap forward here. It's a surprisingly beginner-friendly way to run a free, highly capable private AI directly on your own machine.
You completely sever the connection to remote data centers.
You can analyze sensitive images and write proprietary code entirely offline. Every single prompt and every piece of data stays strictly on your hard drive.
Whoa, imagine scaling to 1 billion queries without ever pinging a remote server.
The scale of that local compute is staggering. The privacy implications alone change how corporations can use AI.
Oh, completely.
But it's also a raw speed play. By running locally, you remove the network latency entirely.
And you eliminate the API subscription fees for that specific compute. Your own local silicon is doing the inference work.
The other major breakthrough happening right alongside local compute is Gemini 3.1 Flash Live. The sources are calling this the official end of the 20-minute YouTube tutorial.
I am so incredibly ready for that era to end.
Same here. You no longer have to constantly pause and rewind a video just to figure out where a specific button is in a software tool.
It's so frustrating.
By sharing your screen, the AI provides real-time visual coaching.
It's literally watching the pixels on your monitor at 30 frames per second.
You just share your screen, and it sees your exact software interface. It processes the visual context and tells you exactly where to click and what to type over audio.
It's dynamic, real-time guidance tailored to your specific screen state. Static learning, where you apply generalized tutorials to your specific problem, is essentially dead.
But I have to ask, is local hardware actually catching up to the massive data centers, or is this just a privacy play?
It's a bit of both, honestly. Local hardware is definitely closing the gap for daily, practical tasks.
Okay.
You aren't going to train a new frontier model on your laptop anytime soon. But for inference, for actually running a distilled model like Gemma 4 to analyze a spreadsheet or write a Python script, modern local chips are more than powerful enough.
We trade ultimate compute power for complete privacy, which is usually worth it.
Exactly. For the vast majority of daily workflows, zero latency and total data privacy easily win out.
Let's push the boundaries even further, because with real-time processing and local hardware unlocked, the AI's core ability to reason is taking a massive leap forward.
And that reasoning power is fundamentally transforming how AI generates media and physical environments.
The sources specifically highlight Meta's Muse Spark. It has a slightly controversial viral trick. It has the ability to reason in parallel.
Parallel reasoning is an absolute game changer mechanically. Older models rely on sequential reasoning. They process tokens step 1, then step 2, then step 3.
Right, it's a linear chain of thought.
Exactly. But Muse Spark processes multiple reasoning paths at the exact same time. It essentially splits its brain, explores 5 different logic trees simultaneously, evaluates them all, and then delivers the optimal solution.
It's incredibly computationally expensive to run parallel tracks like that, but the results are startlingly accurate because it prunes the bad ideas in real time.
We're seeing a similarly massive architectural leap in video generation, too.
Yes. Seedance 2.0 just quietly dropped into the market, and it beat Sora 2 at the one thing that actually matters for production.
Temporal consistency. AI video has historically been plagued by mutating, shifting clips.
The uncanny valley effect.
Yeah.
Sora often generates these disconnected clips where the physics just randomly change from second to second.
It's so distracting.
Seedance 2.0 solves this massive issue. It uses strict video references and sequential generation.
It locks the geometry in place. It keeps characters, physics, and forward motion entirely consistent across multiple scenes.
It stops generating those weird disconnected clips where a car suddenly turns into a bicycle.
Right.
It builds the video using a completely different fundamental architecture.
It anchors the physics engine.
So does sequential generation finally solve the uncanny flicker problem that plagues AI video?
Yes, because instead of trying to guess the whole 3D space from random noise every single second, sequential generation uses a strict visual reference point.
Makes sense.
It calculates the hard physics of the current frame and mathematically forces the next frame to obey those exact same physical rules.
Locking in the physics frame by frame stops the video from mutating randomly.
That's it exactly. It's a brilliant engineering solution to a problem we thought would take years to fix.
So what does this all actually mean for you, the listener? How do you navigate this incredibly complex new ecosystem of planners, local models, and real-time execution?
That is the literal $354,000 question.
It really is. The sources outline a highly specific 2026 AI engineer roadmap.
Right.
It maps out 5 distinct levels. These levels are designed to take someone from an absolute beginner to landing corporate roles that pay up to $354,000.
And the overarching theme of that entire roadmap is skipping the academic fluff.
You must gain the hard skills companies actually need right now. The roadmap zeroes in heavily on mastering Python, system scaling, and RAG.
RAG is absolutely non-negotiable in the current job market.
Could you define that term for us quickly?
Giving an AI a private library to read before it answers you.
Perfect. Companies don't want generic ChatGPT answers anymore. They want the AI to read their proprietary spreadsheets and private data first, and then act on it.
That's why RAG architecture is valued so highly. It securely connects a powerful frontier model to a company's internal reality.
The sources also provide a very pragmatic 2026 AI solidification guide. It explains why platform-specific practical badges matter significantly more right now than abstract theory.
You have to prove you can build and operate real systems. Knowing the theory of neural networks doesn't help a company execute a task today.
If you want to land high-paying technical roles, you have to focus on practical implementation. You also have to understand the specific tools deeply.
The guides break down Claude's current pricing plans as an example.
Analyzing the free, the $20, and the $200 enterprise tiers.
Most people just blindly pick a subscription without knowing what compute they're actually buying.
The guide shows exactly what each tier physically enables in a real workflow. It helps you calculate which one is actually worth the investment for your specific use case.
You have to map the required compute to the specific task. If you're running massive automated notebook LM pipelines 24/7, you clearly need the higher tier.
And if you're just exploring basic planning modes, free is totally fine.
Exactly.
But are traditional computer science degrees becoming obsolete next to these hyper-specific platform certifications?
I wouldn't say obsolete, but their immediate market value is definitely shifting. A traditional computer science degree gives you foundational math and algorithmic logic.
Right.
But the technology is evolving so rapidly that a 4-year university syllabus simply cannot keep pace with tools like OpenClaw or Gemini Flash. Platform certifications prove to an employer that you can safely operate the machinery that exists right now.
Theory is great, but companies pay for the ability to build real systems.
Execution is the only thing that drives the modern tech economy.
Let's pull all of these different threads together. We've covered a tremendous amount of ground in this deep dive.
We really have. We've moved from basic planning architectures all the way to autonomous execution and local reasoning.
The big idea here is undeniable. The era of passively typing a text prompt and hoping for a decent response is completely over. We have officially entered the era of architecture.
We are building complex, interlocking systems now. We aren't just asking isolated questions anymore.
You see it at every level of the stack. We have Claude's self-verifying ultraplan workflow acting as a senior project manager.
Right.
We have the OpenClaw agent executing actual physical tasks on your machine.
We've unlocked secure local privacy with Google Gemma 4.4.
And we finally have perfectly consistent physics-based media generation with Seedance 2.0. The end goal of AI is no longer just generating text.
The goal is building structured, offline, and real-time systems that actually execute our visions autonomously.
It's a much more demanding landscape to learn, but the leverage it provides is infinitely more powerful.
It requires a fundamental shift in how you think. You have to become an architect.
Yeah.
You need to understand the underlying tools, set strict operational boundaries, and manage the execution flow.
And above all, you have to stay curious. The foundational ground is constantly shifting beneath us.
Which brings us to the end of today's deep dive.
But before we sign off, I want to leave you with one final provocative thought to ponder. Earlier, we talked about Meta's Muse Spark and its incredible ability to reason in parallel. We also talked about Gemini Flash Live actively watching your screen in real time.
Two incredibly powerful, distinct technological capabilities.
Think about the trajectory here. If Meta's Muse Spark can evaluate multiple complex logic trees simultaneously, and Gemini can visually process your screen state in real time, what happens the day those two systems seamlessly talk to each other without you needing to be the middleman?
That's the day the architecture builds itself. It changes absolutely everything.
Thank you so much for joining us today. Keep questioning, keep exploring. We'll catch you on the next deep dive.